In this video, I will be going over the solution to the 2025 AIME 1 problem 10. Okay, so the problem says that the 27 cells in this 3 by 9 grid are filled out so that each number in each row is different, and each number in each of these 3 by 3 grids is also different. And so we're just asked to find the number of ways we can order that, right? So to simplify things a bit, I assumed that the first row was the numbers 1 through 9 consecutively ordered. So that can happen in 9 factorial ways, so we'll multiply by 9 factorial at the end. And then also note that in each of these 3 by 1 blocks, right? So let's say we have like numbers A, B, and C here. Well, we can arrange these 3 numbers amongst themselves in 3 factorial ways. And that won't really affect the ordering because they stay in the same they stay in the same 3 by 3 block, and they also stay in the same row, those same 3 numbers. And so we can do 3 factorial for each of these 6 3 by 1 blocks here. So we'll multiply by 3 factorial to the power of 6 at the end as well. So 3 factorial to the power of 6. We'll have to multiply by this at the end. Right now, what we're mainly concerned about is just the number of orderings we can have, right? So let's take a look at the numbers 7, 8, and 9, right? We essentially have 2 main cases. The first case is 7, 8, 9. All 3 of those numbers go in one of these 2 blocks. And so that's obviously just 2 ways, because 7, 8, 9 can either go here, like that, or 7, 8, 9 can go here, like that. So for case 1, we just have 2 ways. So I'll write a 2 down here. Okay, case 2 is where things get a little bit more complicated. So we have 7, 8, and 9, right? So what case 2 is 2 of the numbers 7 and 8 are in this block, and then the third number 9 is left out. So how many ways can that happen in? Well, so we can choose the left out number to go in this 3 by 3 block here. Let's say in 3 ways, right? So 3 ways to choose that number. So let's say we chose 9 to be the odd one out, and so now we have 7 and 8. Okay, so now consider the numbers 1, 2, and 3, right? So 1, 2, and 3, obviously none of 1, 2, and 3 can go in this block, so they have to either go in this block or this block. So we can choose one number out of 1, 2, 3 to go with 7 and 8 on the second row. And so we can do that in 3 ways. So let's say we chose 1. And then the 2 and 3 obviously have to go in here. So we're done with 1, 2, and 3. Okay, so now what about 4, 5, and 6? So 4, 5, and 6. Well, 4, 5, 6, again, I can choose 2 of those to go with 9 here. So like I can choose 4 and 5 to go here, and then 6 has to go in this row. So I have 3 ways again. Okay, and we chose to place this odd one out block in this block, but it could also go in this block. So we have to multiply by 2. Okay, so that gives us a total of 54 ways for the second case. So we have 54 and 2. And so that's it, we're done. So we have 56 times 3 factorial to the power of 6 times 9 factorial. And so now what we have to do is just simplify this. So let's simplify that. 9 factorial times 3 factorial to the power of 6 times 56. We can prime factorize 9 factorial as 2 to the power of 7 times 3 to the power of 4 times 5 times 7. And 3 factorial is just 3 times 2. So then we have 3 to the power of 6 times 2 to the power of 6. And then 56 is going to be 3 cubed, which is 27. Oh wait, no, I'm sorry. That's going to be 28 times 2, which is going to be 14 times 4, which is going to be 7 times 2 cubed. So then we'll have times 2 cubed times 7. Okay, so now we take our powers of 2, which are these. And so we get 2 to the power of 11 here. And then we take our powers of 3, and then we get 3 to the power of 10. And then 5 is just going to be left out, 5 to the power of 1. And then we'll have 7 to the power of 2. Oh wait, I'm sorry, I forgot this 6 here. So we're actually going to add 6 to that 11. So that's actually going to be 2 to the power of 16, right? So 2 to the power of 16 times 3 to the power of 10 times 5 times 7 squared. Okay, so let's get rid of all of this now. So now the problem is asking us for this weird looking product. So we're going to have 32 plus 30 plus 5 plus 49. And that's going to give us 54 plus 62. Oh man, no, that's a 14. My bad. I don't know why I keep making mistakes. Okay. So 62 plus 19, and that gives us our answer of 81.